Hello everyone, my name is Glen Rodrigues and I am here to give a presentation on the stress analysis of composite beams in UAV. So let's begin. Let us start with every every detail of our topic. Our topic is stress analysis of composite sandwich beams used in UAV wings. What is a UAV? A UAV it stands for unmanned aerial vehicle. So by the name, it means it is a flying object in which no man is on board. So the UAVs can be autonomous, which means it can fly on its own with the help of the electronics and computer systems fitted on board, or it can be remote controlled by any human on the ground. Talking composite sandwich beams, these are special types of beams which have three layers. Before talking about that, if we talk about what are beams, a beam is a structural component. I mean, it is a component of a structure. It is a member which helps in bearing the loads acting on the structure. So this is one of a this is a kind of a beam. It is a special kind of beam. It is called composite sandwich because there are three layers. The top and the bottom layers are thin, whereas the middle one is thick. The thin layers are called skins and the middle layer is called core. This type of beams these types of beams are used in UAV wings. Okay, I mean, the UAV wings are not always made of these type of wings, these type of beams. There can be other types also, but this helps in some things. So composite sandwich beams used in UAV wings. Okay, so the materials which are used to make up the top and the bottom layers, which means the skins, are typically carbon fiber reinforced polymer, CFRP or GFRP. GFRP is glass fiber reinforced polymer. The core is often made up of honeycomb, which is Nomex aluminum, or foam. You can see the other materials, PVC, balsa wood, etc. Now let us talk about stress. What is stress? Stress is the internal resisting force per unit area developed inside a material when an external force is applied. So suppose if I have a rod, and if I pull that rod from both the sides, then there will be a tension generated. Okay, the tension is a load, but the stress is a different thing. Stress is the force divided by the cross sectional area of the rod. So so if I have increase in load and also increase in the area, then the stress may increase or it may not increase. For example, if I have 5 newtons of load and 4 newtons of load and 2 centimeter square as the area in the first case, and in the second case 10 newtons of force and 5 centimeter square area. In both the cases the stress is same. The load has increased in the second case, but the stress has remained constant because the area also increased in the second case. So that is stress. There are different types of stresses. What I talked about just now is was tensile stress. Then we have compressive stress, we have shear stress, bending, torsion. Let's talk about stress analysis of composite beams used in UAV wings. A wing has to deal with aerodynamic loads, like we have lift is generated by aerodynamics. So then drag is generated by the air coming forward from the air, I mean from the trailing edge of the wing. So these are all aerodynamic loads. A wing has to bear all these load forces. We have a distribution here now. The face sheets, I mean the skins, bear bending stresses, whereas the core bears shear stresses. Talking about the main stresses in the beam, bending stresses in skins. Okay, now what happens is, when due to the aerodynamic loads, the wing tries to bend upwards. Okay, due to this, there is compression in the top skin, I mean the top layer, and there is tension in the bottom skin. Why is this so? Because the wing tries to move upwards due to the aerodynamics in the air. The shear stress is mm, mainly handled by the core. Now, why is this good for UAV wings? This the composite beam type, mm, they are good because they are strong and light, which is good for better endurance. What is endurance? Endurance is the total amount of time an aircraft can stay in air uh, in given amount of fuel. So if the aircraft's wings are strong as well as light, it will help to stay it for longer time. High stiffness, wings don't bend too much. Now if the wings start bending too much, they will cause problem. So this wing, I mean this beam type, helps the wing to stay strong. This wing type is efficient. Why we are calling it efficient is because the loads are well distributed among the layers, the top and the bottom. The skins bear the bending stresses, whereas the core bears the shear stresses. So they have a good distribution of loads within themselves. Okay, let's conclude. In conclusion, we have in UAV wings, UAV sandwich beams, skins carry bending stresses, tension and compression. The core carries shear, and together they make the wing light and strong. So this was the um, stress analysis of the sandwich beams in UAVs. Thank you very much.